All right, let's get right into it. What's the real difference between software that shines and software that, well, doesn't? It's not just about the code. It's about something much deeper, the blueprint underneath it all. And that's what we're talking about today, the basics of software architecture.
I mean, you've probably seen this play out, right? You have two projects, both with really smart people, aiming for the same thing. One of them just takes off. It's successful for years. But the other one, oh boy, it just becomes this tangled mess. It's impossible to change, a total nightmare to maintain. So what's the difference? It's almost never about who wrote the cleverest code. It's all about the quality of the foundation.
So the secret sauce is just better design. But here's the thing, and this is super important. Design isn't just one single activity. You have to think about it on two completely different levels. There's the high-level, big-picture view, and then there's the down-in-the-weeds, detailed view. And this table here breaks it down perfectly. Over on the left, you've got detailed design. This is the stuff a lot of us do every single day, picking the perfect algorithm, figuring out the right data structure, the calling sequences. Think of it like deciding on the specific type of bricks or the gauge of wire you're going to use in a house. But then on the right, you have architectural style. This is the blueprint for the whole house. It's asking the big questions. What are the main rooms? How do they connect to each other? What's the overall structure going to look like? You figure this out way before you start worrying about paint colors.
Okay, so here's probably the best way to think about it, especially for all you database pros out there. Think of your software architecture as your database schema. Seriously. It's that foundational structure, right? It dictates your tables, your relationships, all the constraints. You can't just start throwing random data into the database. You have to follow the rules of the schema. Well, guess what? Software is exactly the same. Let's hang on to that schema analogy. It's going to be really helpful. And this quote really nails why architecture carries so much weight. It's all about deciding on the core elements of the system, the pieces that are really, really hard and expensive to change later on. You're not just drawing up a plan, you're basically pouring the foundation in concrete. If you get that wrong, well, the whole building is at risk from day one.
So that brings up a really important question. Why is getting this foundation right so incredibly crucial? I mean, especially as our systems get more and more complex, why can't we just, start coding and figure things out as we go?
Well, the thing is, software architecture as a discipline didn't just pop up out of nowhere. It was born out of necessity, forged in the fire of this exact problem. As programs just exploded in size and complexity, developers desperately needed a way to manage the chaos. An intentional, well-thought-out architecture is basically our #1 defense against a project collapsing under its own weight. Okay, let's make this real with a classic example that you use every day, the layered architecture of an operating system. Just look at how this is put together. Way down at the bottom, you have the actual hardware. Sitting right on top of that is the kernel, which manages all that hardware. Then you have the OS services, providing all that useful functionality through really well-defined interfaces. And finally, at the very top are the applications we all use. The key thing here is that each layer pretty much only talks to the layer directly above or below it. And the power of doing it this way is huge. This isolation means you can, say, completely upgrade your computer's hardware without having to rewrite your web browser. That's amazing, right? But the separation also comes with a trade-off. Because requests might have to pass through multiple layers, you can sometimes take a small performance hit. And that is a classic architectural decision. You're trading a little bit of raw performance for a whole lot of maintainability and flexibility. So here's the crucial point, the big takeaway from all of this. Your detailed design choices, the algorithms you pick, the functions you write, they are all guided and constrained by the high-level architecture you've already set. It's like you wouldn't try to build a skyscraper on a foundation that was poured for a small house, right? And you're not going to start writing complex queries before you've actually defined your database schema. It's a simple rule: design always follows architecture.
And there you have it, the bedrock basics of software architecture. If this explainer helped you put some of the pieces together, do me a favor and hit that like button, subscribe for more, and maybe share it with a friend who's building something awesome. So I'll leave you with this one final thought. Every single program, no matter how small, has an architecture. It's there whether you planned it or not. So the only real question is yours intentional? Thanks for watching.